There it is. So I showed you last class that I put a practice assignment, and all it is just making sure that you're capable of uploading. Can someone just type in? Oh, so Jordan says they're here. Thanks, Jordan. What was I saying? Could someone just type in yes or no? I guess you couldn't say no. Did you get a notification that I had put that assignment on? Did it somehow now? Oh, no. Okay, fair enough. I will always tell you that. Don't worry. Okay, I appreciate that. I will let you know. You know the test is on Friday, and so that's where it's going to show up. We'll talk about it, so don't worry about it. Mrs. Rollick's in the process of making it right now. So I was just curious if you got an notification. You didn't, we'll let you know. The test is going to be on Friday. It won't be that long. It'll all be good. In the assignments, as I said, on Brightspace, when you click on class tools and assignments, there is a cheap little assignment that all it is I want you to draw me a picture, put your name on it, and then upload it. And I'm just getting you ready for Friday's test. So that's all it is. It's just a practice, nothing serious. I had to copy it on Google Docs to do it. Is there a better way to? I'm not going to lie to you, Karen. You guys are going to have to figure that out. I know Brightspace for about the last 72 hours. That's how long I've been using it. So if this was Google Classroom, I know a lot more about Google Classroom. I know Brightspace for truly 3 days. And I'm sure, you know what's interesting? I wonder, could you just open it and then, because you don't actually have to print it out. You could just open it up on your computer, look at it, and then put it on scrap paper. It's not as if you had to type or print it out. So, because I know that some students don't have printers at home, which is fine. All right, my students. Where did it go? We were just playing around with a couple of equations during the break. We were learning how to graph things on the calculator. I remind you, the calculator must have y equals. You get y equals and you type them in. There is a huge difference on your calculator between a negative and a subtraction. A negative is up high. A subtraction is bigger and lower. If you're getting a syntax error, I bet you that's what it is. I also remind you, if it's not in y equals, you got to get your equations to y equals. All right? Now, the calculator isn't that big of a deal. We are much more concerned at the grade 10, 11, 12 level with the algebra. All right? So we're going to spend today and tomorrow and Thursday just practicing our algebra skills. Now, do me favors. Whoever's got their microphone on, turn it off if you wouldn't mind, please. What I was going to say is this. The algebra skills are so crucial if we're going to go into -1, -2 type thing. If you're wondering, am I a -1 student? Ask yourself how well you can do these units algebraically. The calculator isn't that big of a deal. It really isn't. So we're not terribly concerned about the calculator. It's the algebra skills that we're more concerned with. All right. There are two techniques to solve these things algebraically. One of them is the substitution method. All right. Both of them, the names actually tell you exactly what to do. We don't care which one you use. Some of you will say, oh, I like substitution, and you're going to do substitution for all the questions. Some of you are going to do elimination. Fine by me. In the grand scheme of things, we're not going to tell you which one to do. We will say solve algebraically, which means you can use the substitution method or you can use the elimination method. Today, you only need to know the substitution method. That's all we got. All right, the substitution method. I'm on page 12. The substitution method literally says get one of the equations to either y equals or x equals, and it makes no difference which one. Clearly in question 1, we have figured out that x is equal to 4. You are about to take that 4 and substitute it in. You don't need to make a big mess, but I'm taking that 4 and I am substituting it into the x. All right? So now this becomes 3. Hey, what's x? X is 4. Plus 6y is equal to 6. Notice how I substituted the 4 into the x. Well, now it's algebra. 3 times 4 is 12, plus 6y is equal to 6. How do you get rid of an adding 12? You will subtract 12 from both sides. And you have 6y is equal to -6. Again, the 4 went into the x. 3 times 4 is 12. Move the 12 to the other side via subtraction, and 6 minus 12 is -6. How do you get rid of a multiplying 6? I believe you divide by 6, and we have just figured out that your y value is -1. We now know that x is 4 and y is -1. The solution to this system is 4, -1. Now, you will notice I've got examples 1, 2, 3, 4, 5, 6, 7. I got 7 of these things, and then your assignment is actually going to be on page 15. So don't think that this was a one-off. I'm doing this over and over and over again. I am going to do the substitution method over and over again. So to recap, you get one of them to x equals or y equals. You substitute it in to the other equation, and you solve for your missing variable. That's why it's called the substitution method. All right, let's take a peek here. Example number 2. Now, example number 2 is a gift. It's already in y equals, which means we're about to take this 5x minus 1, and we're going to substitute it in to that y, because y is 5x minus 1. So here's the 3x plus, hey, what's y? Y is 5x minus 1 equals 15. I realize I have access to different colors. You don't need to. But notice that I replaced this y. I substituted 5x minus 1 into the y right there. Now you have an equation with only x's. Please solve it. 3x plus 5x, I believe, is 8x minus 1 is equal to 15. To get rid of a subtracting 1 is to add 1. 8x is equal to 16. How do you get rid of a multiplying 8? You divide both sides by 8. And if I am not mistaken, my x value is 2. I'll let you kind of catch up, and I'll repeat myself. I already had a y equals, so I substituted the 5x minus 1 into that y. And I had 3x, because the 3x stayed. What was the y? Oh, it was 5x minus 1 equaled 15, and it stayed. Now I combined up my like terms. 3x and 5x became 8x. Minus 1 is equal to 15. To get rid of a subtracting 1, I added 1 to both sides. 8x is equal to 16. How do I get rid of a multiplying 8? Divide both sides by 2.
If we were going to graph this, 2 would be in place of x, but what would we put for y?
No. Okay, if you were going to graph this, you wouldn't even do this work. You see this? It's not here if you're graphing this. If you're graphing this, there's your y1. Your y2 would have been negative 3x plus 15. If you were graphing this, negative 3x plus 15. You're trying to combine two different things. Either graph it or do it algebraically. You don't do both. So if you were going to graph this, here, you now have y1 is the 5x minus 1. Y2 is negative 3x plus 15. Throw that into your calculator. Tell me where they cross. And you will get an answer of 2 for the x.
Oh, okay. Thank you.
No problem. No problem. It's a great question. Now, let's be honest. We now know that x is 2. We have to get the y. I know that my answer is 2 comma something. I don't know what the y is yet. I need to get the y. It's 2 comma something. Well, all you do is you put the 2 back into your isolated variable. 5 times 2 is 10 minus 1 is 9. The y value is 9. Again, I took this x is 2 and I put it back into my equation to figure out what y is. 5 times 2 is 10 minus 1 is 9. This is the substitution method. The substitution method, again, gets somebody isolated. Don't care who. It makes no difference. Substitute it into the other equation. And you will get half your answer, the x or the y. Once you have 1/2 of the question answered, go put it back into your isolated equation and figure out your other half.
If there was a number in front of y, would we just put like the y equals from the first one into the brackets?
Well, why don't we play with number 3 here? I know exactly what you just asked, and let's play with it right now. Shall we? Here is what she just asked. Notice, number 3, we already have x equals. Yay! You are about to take this 3y minus 7, and you are about to substitute it in for this x right here. All right? So I think, Karen, here's what you were asking. Notice the 3. Whoops. Sorry. The 3 is already there. Now, what's x? X is 3y minus 7. So I think what you were asking was, what happens if there's a coefficient in front of the variable that you substituted? Leave it and substitute in your missing variable. And now you've got plus 2y equals negative 10. I got the x equals. I substituted the 3y minus 7 in for the x, and it's 3. Notice the black 3 stayed. Hey, what's x? It's 3y minus 7. Then it's the plus 2y is equal to negative 10. All we're about to do now is a little algebra to isolate the y. Step 1, fire the 3 into the bracket. 9y minus 21 plus 2y is equal to negative 10. Combine up some like terms, 9y's and 2y's, 11y's minus 21 is equal to negative 10. All I did was I combined up my y's. Got 11 of them. How do you get rid of a subtracting 21? You add 21. 11y is equal to, I believe that negative 10 plus 21 is 11. Can anyone confirm that your y value, and no, I have no idea why I asked if anyone could confirm, because you can't even say anything. I believe the y value is 1. Now I will pause and refresh what I just did. Equation 1 was already x equals. Somebody has to be x equals or y equals. The 3y minus 7 substituted in to this x. So it's 3 times 3y minus 7 plus 2y is equal to negative 10. Now, 9y and 2y is 11y's. To get rid of a subtracting 21 is to add 21. Move it over, and I got 11. Divide both sides by 11, and I believe that the y value is 1. I know that my answer is something, comma, 1. That's the answer. That's the solution to this system. The question becomes, what's the x? Well, you take your y, and you substitute it back into, hey, what's x equal? 3 times 1 is 3. Minus 7 is negative 4. Karen, is that what you were wondering? What happens if there's a coefficient in front of the variable?
Yeah, thank you.
That's what I'm here for. I mean, this is how math teaching works. You start very basic and you build up, right? We get more and more complicated as we go along. All right. Now, this is good. Like I said, I think I've got 7 of these, and then I'm going to let you work for a while. This lesson is like the key. Today, tomorrow are the key to the unit. Substitution and elimination. You will use these techniques for the remainder of your mathematical career. I guarantee it. All right. Notice the second equation is already y equals. Great. I'm not saying you have to circle this. I'm just trying to show my students what's going on. I am taking this y equals, and I'm going to shove it right there in for y. Thus, 2x plus, right, because that's what the black is. Hey, what's y? It's negative x plus 3 is supposed to equal 5. I have the ability to use colors, so I'm trying to say that black is original, 2x plus. Hey, what's y? Negative x plus 3 equals 5. Well, combine some like terms. 2x's and the negative x is indeed a singular x. Plus 3 is equal to 5. To get rid of an adding 3 is to subtract 3. And I believe that my x is 2. I believe the solution to this system is 2 comma something. Okay. Well, now all I do is I go and put this x is 2 back into the equation. Negative 2 plus 3, I think, is 1.
Mr. Chandler?
Yeah.
For that question, because we already moved the negative x into the former equation and we got 2 out of it, would that mean that we use just positive 2, or would we still have to do negative 2?
So it's 2, but when it goes in here, it becomes negative 2. The answer is 2, but when 2 goes in, it becomes negative 2. Negative 2 plus 3 is 1. Now, I'm just going to... Oh, go ahead.
Oh, so it doesn't matter that we already used the negative in this equation. We still use it in the other one?
Correct. Now, wouldn't you put 1 into the equation instead of what y equals? So wouldn't it be 3x plus 2 times 1 equals negative 10, for example, example 3. Okay, my apologies. Here's the problem with you guys typing. Because this is so small, I have to come. So Jacob, I'm not totally following what you're talking about.
Okay. So for example 3, you got y equals 1.
Yes.
And then you plugged 1 in for x equals 3y minus 7.
Yes.
Wouldn't you plug 1 in for 3x plus 2 times 1 equals negative 10?
Who cares? Go for it. Fine. Show you something. Do you mind if I erase some of my work here? You're saying put this 1 into this equation. Hey, I am nothing but accommodating. Sir, you're now saying this. 3x plus 2 times 1 is equal to negative 10. Well, 3x plus 2 is equal to negative 10. I apologize. How do I get rid of an adding 2? Subtract 3x is equal to negative 12. How do you get rid of a multiplying 3? Negative 12 divided by 3 is negative 4.
Mr. Chandler?
Yeah.
I think you messed up. I might be wrong. Oh, wait, no, never mind. I am wrong.
Yes, you are. On this one, I know I'm right. So, Jacob, the point being, I don't care where you put the y equals. You can put the 1 into this y. You can put the 1 into this y. Either equation will get you your other x.
Okay. Okay, thank you.
Yeah, it makes no difference. Now, you want to know the reason I used the first guy? He was already set up as x equals. Less work. Remember, I'm lazy. Okay, so whoever's talking about cookies and preheating the oven, please stop, because if I have to stop my class to actually read the questions, I don't want to have to go through this garbage. All right, you guys want to text each other all this garbage, go for it. But I don't need to read it if I'm trying to catch up to see what questions my students are asking me. So, what this is saying then to us is that you can put it into either equation. You notice how I had this 2? I could have put this 2 in here. 2 times 2 is 4. 5 minus 4 is 1. Same answer. It makes no difference how you get your second answer. Either equation is fine by me. All right? All right, cool. Let's go to the next page. More of the same. Hello, sir. Oh, a mouse. Thank you.
Nope. Webcam.
Oh, I don't know why I said a mouse. I don't
but
even,
you have a set from home.
This is my home one, absolutely.
There you go.
And to be honest, what I might do is set up 2. I might have 2 going at the same time.
Your call.
Yeah, but this one is my personal one.
Okay.
Thank you.
No worries.
Sorry about that, students. Now we get to the actual crux of this question. Notice, unlike the first 4, I haven't isolated a variable for you. The first 4 questions all had somebody isolated off the top. Now you have to do your work. If we were in class together, I would then look at the class and I would say, which would be easiest to isolate? Do I really want to move the 5 over and divide by 4? I'm going to get 26 divided by 4 and 5 divided by 4. Isolating x in that first equation is atrocious. Moving the 4x over and dividing by 5 is no better. Now, you might say to me, oh, wait a second, look at this 3x. Divide both sides by 3 and you'll have x equals. I don't deny that. But is anyone else noticing that if we move the 9 to the left, we'd have a beautiful y equals? Meaning, you've got to analyze something and decide who's easiest. I think the 9 moves over, giving me 3x plus 9 is equal to y. To me, isolate y in equation 2. I can now take this 3x plus 9 and substitute it in for y in equation number 1. I am taking equation number 2, moving the 9 back, and I will isolate it and substitute it in for y. I now get what Karen was asking a few minutes ago, and we get 4x, who's black, plus 5, who's black. Now, what is the actual y? Y is 3x plus 9, and it equals 26. So to repeat, most often, you're not given an equation who is set up in x equals or y equals. You've got to isolate somebody. I move the 9 back, and I get positive 9. I now substitute in 3x plus 9 in for y, and I get 4x, same, plus 5, same. What's the y? 3x plus 9 equals 26. All right, here I go. Fire the 5 into the bracket, and I think I have 4x plus 15x plus 45 is equal to 26. All I did, fire the 5 into the bracket. Combine up some like terms, 4x and 15x, I believe is 19x plus 45 is equal to 26. All right. How do you get rid of adding 45? You subtract 45 from both sides. And I've got 19x is equal to, now, I don't mind if you use a calculator. If you need to go 26 minus 45, who am I to judge? I'll just grab my calculator over here, pretend I'm a student. 26 minus 45 is equal to negative 19. Well, that's convenient. And divide both sides by 19. And I believe that x is negative 1. Put that back, and I'm going to give you a second to sort of absorb what I did. I will review. I moved the 9 over in the second equation to get a y equals. I substituted in for the y in equation 1. So it was 4x black plus 5 black. Y is 3x plus 9. Then 26 black. Fire the 5 into the bracket. Combine up like terms, and I figured out that x was negative 1, which means my answer is negative 1, comma, something. I don't know what the something is, but it's something. Now, how do I get y? You have 3 choices. You want to put the negative 1 in for the x right here and solve for that y? Go for it. You want to put the negative 1 into that x right there and solve for that y? Go for it. You want to put the negative 1 into that x right there and solve for that y? Go for it. I don't care where you put the x in as long as you solve for your missing y. I'm going to put it here because it's easy. 3 times negative 1 is negative 3 plus 9. Negative 3 plus 9. I believe the answer is 6. Agreed? Now, not picking on Karen, but she had asked a question on the previous screen. Well, what happens if we were to do this graphically on our calculator? Oh, you would have gotten the second guy to y equals. You would have gotten your first guy to y equals by moving the negative 4 over and then dividing by 5. You would graph your 2y equals, and I guarantee you would get that answer. Whether you solve graphically or whether you solve algebraically, you will get the same answer. Now, is anyone in the, okay, fair enough, no garbage there. All right. I'm hoping that this is becoming a little easier with every single question. That's the goal. All right. All right. Well, shall we try some number 6? Number 6, I think, is actually set up. Notice he's already y equals. Meaning, I get to take this 2/3 x minus 3 and substitute it in for the y. Now, I have very good news. You might be concerned about that fraction, but it's going to disappear pretty darn quick, which is nice. So here I am, 5x in black, stayed. Minus 3 in black, stayed. What's y? Y is 2/3 x minus 3. And it equaled 18. Notice I took the the 2/3 x minus 3, substituted it in for this y, 5x black, stay. Minus 3, what's y? 2/3 x minus 3 equals 18. Now, if you need to use a calculator, I totally respect that. I am not going to question you. But when you fire this 3 into this bracket, it actually gets rid of that fraction quite nicely. 5x. 3 times 2/3, I'm looking at a negative 2x. Negative 3 times negative 3 is a positive 9. Be very careful. A negative times a positive is negative. A negative times a negative is positive. And look at that. And we designed the question this way. A multiplying 3, dividing 3, canceled out. We're not here to try and kill you. This isn't trying to get really weird answers. Combine up our lighter terms. 5x minus 2x is 3x. Plus 9 is equal to 18. I'm sorry, did someone ask me a question there? I apologize. I heard something, but I don't know what I heard. Minus 9, 3x is equal to 9. Divide both sides by 3. Is anyone confirming that the x solution is 3? I'm going to just 3 as my x solution. I have an answer of 3 comma something. I don't know what the something is yet. I'll get it. But my answer up here is 3 comma something. I don't know what the something is yet, but you can now put your 3. You have x is 3. You can decide to put it into the first guy. You can decide to put it into the second guy. You will get the same answer either way. I believe that 2/3 times 3 is 2. 2 minus 3, I believe, is negative 1. I believe my answer is 3, negative 1. What are our thoughts? Just going to see if anyone's writing something. Nope, good, fair enough. Shall we try the last question of the day, and then I can give you a good half an hour to work? That's my intention. All right.
Mr. Chandler, there's a question in the chat about how you got Y in number 6.
I missed that question. Oh, it just came in. Sorry. How did you get Y in number 6 again? Not a problem. Thank you for pointing that out. We have x is equal to 3. When you get the first half of your answer, whether it be x is this or y is that, you always take it and shove it back into the original question. I am taking this 3. I'm not going to make a big mess, but I'm taking this 3 and I am going to shove it either into here or here. It makes no difference. You know that x is 3. Tell you what, I'll even play with this guy. Tell you what, I'm just going to erase this. I'm about to put a 3 into that x right there. 5 times 3 minus 3y is equal to 18. 15 minus 3y is equal to 18. Move the 15 over via subtraction. Negative 3y is equal to 3. Divide both sides by negative 3, and y is negative 1. When you get the first half of your answer, shove that value, x or y, into either equation at the beginning. It makes no difference. And then you find the other half. So I believe that x was 3 and y was negative 1. Doesn't matter if you put x is 3 here or if you put x is 3 here. Either way, your x's will disappear and you will solve for your missing y's. Okay, thank you. Perfect. That's wonderful. All righty. I'm going to do this last one slow because I really want you guys to try and do it without me. We got 10 minutes to get it done, then I can give you half an hour. I'm going to answer my phone. A moment, please. Afternoon, Don Kelly speaking. Good, thank you. Yes. Okay, tell you what, I'm like 10 minutes left in my lesson. Can I just finish my, then I'll come talk to you when I let the kids do some work? Thank you. Bye. Sorry about that, students. Now, when you look at this question, you might say to me, oh, look at equation 2, the guy on the bottom. Divide both sides by 12, and you'd have an x equals. I concur. Oh my goodness, look at ugly fractions. I don't like fractions. So it's not that I'm saying don't do that, but don't do that. Now, you might say, oh, okay, fine. He doesn't want me to divide by 12. Move the 3 over, divide by 4. Ooh, that's just as bad. Notice how equation 1 has a singular y. As far as I'm concerned, I think that equation 1 moves the y to the right and the 7 back. As far as I'm concerned, my apologies, I was about to write the equation again. As far as I'm concerned, -7 is equal to y. I think the most logical step here is to move the y, the negative y, to the right and become positive, bringing the 7 back to the left. And now I think I have a beautiful y equals. I think this y equals can go right there. That's my intention. I'm about to put that y in as 3x minus 7. All right. So what do we got? Here, I'll do it in black because that's what I've been doing all class. 12x stayed equals 4. Now what's y? Y is 3x minus 7. And then it equals, plus 3. Notice 12x black stayed 12x. Equals 4 equals 4. 3x minus 7 is y plus 3. I will fire that 4 into the bracket and I will figure out what the heck x is. Meaning 12x is equal to 12x minus 28 plus 3. All I did here, 4 times 3x is 12x, 4 times negative 7 is negative 28, plus 3. Now, time to combine some like terms. Bang, bang. All right, 12x is equal to 12x minus 25. Agreed? Now, this one is weird. I don't deny it. This one is completely weird because you're going to say, ooh, let's subtract 12x from both sides. I now have 0 is equal to negative 25. In what world does 0 equal negative 25? And I know what you're thinking. It doesn't. And you're right. So what does this mean? There's no solution. These two guys are parallel lines. These two guys are running side by side. I can tell you that x equals the empty set. I can say x equals no solution. When you get 0 equals something, when you wipe out the x and your y's, but you don't wipe out your constant, you have parallel lines. If, and I only use Karen's name because she's been talking about it, if you were to graph this, if this was your y1 If you move that 3 over and divide it by 4, you will get parallel lines. How do I know this? This guy's slope is 3. What's 12 divided by 4? 3. The same slope. These guys are parallel. There is no solution here. All right. So, no question. Excellent. Here is what I would like to do. I would like to give you some time to work. Now, I've been doing this for longer than you've been alive, so I know exactly what's about to happen because it happens in class. Whether or not we were doing this remotely or whether or not we were in class, I'll give an assignment, and I know full well that some of you are about to shut down, turn off your camera, and go do anything but mathematics. Okay? I can't stop you. But when it comes to Friday's test, then it's going to be a disaster. You've got to practice. I'm about to give you half an hour to please work page 15. Now, 15 only actually has 6 questions. I'm giving you half an hour to do 6 questions. Now, you might say to me, wait a second, what about these ones? Well, it simply says, is 1, -2 a solution? Can you put 1 in for x, -2 in for y? Do you get the right-hand side? Can you put 1 in for x, -2 in for y, and get the right-hand side solution? If yes, it is a solution. If no, you are not a solution. So the first 3 are simply putting 1 in for x, -2 in for y. Do you get it to work for both? If yes, you're a solution. If no, you're not a solution. Now, I'm going to help you out. Number 2 says solve by substitution. This is a gift. You want to move that x over and get y equals? Good on you. You want to move the 2x over and get y equals? Fine with me. Heck, you could move the y over and get x equals. You got 3 choices in A. In B, my personal thought, I'd move the 4x over and get y equals 5 minus 4x. In C, I don't care. One of these x's is moving over to the other side, and you'll get a y equals. In D, I'd probably move the y over and get x equals. In E, either y or x equals. In F, either x or y equals. So, my students, can we please return at 3 p.m.? If you're going to turn your cameras off, so be it, but I need you back in exactly half an hour at 3 p.m. so that we can answer some questions, I can talk about what we did today, and we can move forward, and I will be done by well before 3:14. So we're not going to 3:14 today. Can you please return by 3 p.m.? You've got the assignment. I'm stopping recording.